Hey guys, welcome to the high ground. My name is Fabio and today we will be talking about the bread and butter of LandNav, how to work with a map and a compass. This video is the third part of my LandNav series. So today we'll be talking about types of compasses, the parts of a compass, and then how to determine your position with a compass. In the next video, I'll show you how to identify terrain features and how to navigate to a point regardless if you can already see it or not. Now, which types of compasses are there? Actually, there is a huge amount of different builds for compasses. They all have special purposes. I want to introduce you to three types of them. The first one is the baseplate compass, and it basically looks like the compass I have in my hand here, just without the lid. So I'll also just show you a picture right here. This is a baseplate compass. A baseplate compass is an excellent tool for map work, for planning your routes. It is not so good when it comes to shooting exact bearings and general field work. So for me, the baseplate compass is really something you can use in the outdoors, but it has some serious drawbacks, especially when it comes to the shooting of bearings. It's just not as exact as the other types I will show you. The second compass type I want to introduce you to is the Lensatic compass, or what we know as the standard military compass. To be honest, I couldn't find my old compass, so I'll also show you a picture somewhere here so that you have an idea what I'm talking about. This compass is very good for actual field work. You can shoot very exact bearings with it, and it is also very rugged and stable, so it takes a lot of punishment before it actually breaks. On the other hand, one of the drawbacks of the military compass is that it is just not as good for map work as the baseplate compass is, and so in the planning phase it is just not as comfortable to work with. And the last compass I'd like to show you is the one I have actually in my hand. It's a so-called mirrored baseplate compass or sighting compass. It aims to unite the best of the military compass with the best of the baseplate compass, and it is actually a very good all-rounder. It can shoot fairly accurate bearings. You can do a lot of map work just due to the transparent baseplate it has. And for me, it's more or less the gold standard for civilian outdoor work. One thing I'd like to add before we really look in detail at this tool is the topic of global compasses. So if you buy a cheap compass, it is likely that it only works in the hemisphere you bought it in. So if you buy a cheap compass in Europe or North America, it is possible that it only works in the northern hemisphere, just due to the fact that the magnet lines in the southern hemisphere are different. And you have this little needle in here that should show you the north. And it's possible that, for example, in the southern hemisphere, this needle is actually pressed down by the different magnet lines and doesn't work properly. So I would recommend to go ahead and buy a little bit a better compass that works worldwide. Working with a more quality compass is generally also easier. And if you have a global compass, you generally should know that just by looking at the packaging. It should include the fact that it works worldwide. For example, my compass here is the Suunto MC2G. The G stands for global, so I can use them in both hemispheres, northern hemisphere and southern hemisphere. Okay, now let's actually get to the parts of a compass. Now, if we look at our compass, we can, as a first step, roughly say that we have a lid, a base plate, and the housing or vial. These three parts, they all contain different tools and are used when working with a compass, and we will now have a detailed look at them. Now let's look at the lid first. You can see here on the outside of the lid you have measuring tools, and these lines, they are specific to this compass. Not every compass has them, but this scale shows you which distance of contour lines means which angle of the respective slope. We have this for contour lines with 20 meters of distance on a 1 to 25,000 scale map. We have this for contour lines with 50 meters of distance on a 1 to 25,000 scale map. And we have this for 40 feet on a 1 to 24,000 scale map. So this is basically a measuring tool on the lid. Inside of the lid we can see several things. First, we have sights up here and down here. Then you can see that we have a mirror on the inside. This mirror is used to actually read bearings or to rotate the bezel in the correct position. I'll show you that a little bit later. And if you look carefully, you can see that we have a little line on the mirror that goes from the top of the lid all the way down. It's here. And this line is the so-called sighting line. We will use this line a little bit later to make sure that we actually hold the compass straight. That's it for the lid. Let's go to the housing and the vial of the compass. Since the bottom of the vial is transparent, I have put my map behind it just so that you can properly see what's going on. So first we have the magnetic needle, and the red part of this magnetic needle generally points towards the north. Then up here, this little garage for the magnetic needle is the so-called orienting arrow, and around here we have the azimuth ring. We can actually use that and turn it. My fingers are cold, sorry. Like this. This is the azimuth ring. These would already be the basic parts of the housing and the vial, but since we don't just only want to be okay at what we're doing, but we really want to be good at what we're doing, let's look at it in a little bit more detail. As said, let's be a little bit more precise. Those vertical lines you can see here are the so-called azimuth lines. We will need them later to orient our compass on the map. Then here you can see this black arrow. This is a so-called inclinometer. So inclinometer, it just shows you how steep a slope is if you shift your compass to the left and to the right. And behind there, this scale, this one, this will show you the actual steepness, but it will also double as declination correction scale. Now, if you don't know what declination is or what this declination correction means, please go back to part 1 of this series, where we look at the map and where I explain in detail what declination is, how it works, and if it is actually important for you. So I have turned my compass around now, and you can see this little screw. If I turn this little screw, the inner vial of the housing will shift, and you can see here a declination index and the declination correction scale. So every little dot here is 2-degree declination correction, and so you can put in the correct declination for your position. Here in Switzerland we have generally a declination of roughly 2 degrees. I have left it with 0 just for us to make it a little bit easier, and don't confuse anybody with the numbers you might see on the compass. One small thing for the front side before we move on. This needle within that vial is damped with fluid. There are also more cheaper compasses that don't have a fluid dampening, but I highly recommend to get one. It gets the compass more stable. It's easier to hold the bearing because the needle is not so shivery. It doesn't spin around as easily. So that's something you can look for when you buy a compass. Now we looked at the lid and the housing, the vial, and I know that we already learned a lot of new technical terms. And I promise you, we will get to use the compass in a few minutes, but as a last point, we really have to look at the baseplate. Now, as you can see, we have a lot of measurements and numbers on the baseplate. It's pretty simple. You have a ruler here and here in centimeters and inch. You have an index for kilometers on certain map scales. So we have from here to here 2 kilometers on a 1 to 50,000 scale map. We have 1 kilometer on a 1 to 25,000 scale app. Down here, this arrow is called the direction of travel arrow. And we have here azimuth index lines. We have them here and we have one up here. You can see a lot of the parts of this compass are glow in the dark, but that's not what you necessarily always need. Last but not least, we have a lanyard on our base plate. I'll show you a little bit later how that is used. You can just take it to basically aim like with iron sights over the compass, but we will have a look at that in a minute. Again, sorry, this was quite a long and detailed explanation, but now we will be able to communicate effectively with each other and make sure that we understand how to use a compass. In the next step, we want to learn how to determine our position with a compass and a map. For your information, I'm not standing in the midst of a forest. I'm actually on the edge of a forest. On my left is a little creek, and behind of that is a village. This is quite useful because we will have to work with landmarks in order to be able to triangulate our position. If you remember the last video about terrain association, there we needed two terrain features in line in order to draw a line and then triangulate our position on a map. The big advantage with a compass is that I can determine my position wherever I am as long as I have a terrain feature and a line I'm moving on, like along a river, or if I have two terrain features. But I don't have to search for terrain features that are in line, etc. So that's one of the big advantages with a compass. And of course, the compass is a little bit more precise. If all this talking about terrain association and terrain features sounds something weird to you, maybe go back to the second video of this series. I'll link it below in the description. There I explain how to navigate only with a map and terrain association, but without a compass. Now, let's go ahead and see if we can find such a terrain feature that we can use to determine our position. Okay, since we want to use a pretty small landmark, something that is, well, very specific, you can see there in the background between the two houses, there is a small red bell tower. And we will shoot the bearing to this bell tower from our position. Okay, and now we have to shoot the bearing to this bell tower. And as you can see right now, I'm using the lanyard, but you could also just do it like this if you're able to hold it stable. I found the lanyard quite helpful because I can just use it a little bit like iron sights, and I'm able to hold my compass more stable like that. But as said, it works like this as well, and then you could basically just take away the lanyard, you wouldn't need it. Okay, so now this is my perspective. And bear with me, it's not too easy to film that one, but what we have to do is we have to align this side that we have here with the church tower. And that's behind there roughly. So, and now we have this sighting line on our mirror, and let me open it up a little bit more so that you see more of the compass. Yes, so if you can see, if I move the compass back and forth, the sighting line that you have here moves with it. And we have to make sure that the direction of travel arrow that we have on our base plate is in line with the sight so that we can get a clear and straight bearing. Okay, we did this. Come on, give me a sharp picture. And then all we do is we turn the rotating bezel until the garage is in line with our magnetic needle. So you can see that here on the arrow, the garage is in line with the magnetic needle. And then we already shot our bearing. I will just make sure that it is still correct because it's a little bit hard in front of the camera, but give me a second and then we will transpose it to our map. Okay, now we shot the bearing and now we can check the actual azimuth number. Here you can see we are approximately 10 degrees to the northeast. That's how we just turned the bezel, the vial, and now we will transpose that to our map. As said, we need to get this bearing onto our map. And we have two variants on how to do that. It is often taught and shown that we have to first north the map. And that's not necessarily wrong. So what means northing the map? It means that the northern part of the map should show straight to the north. How can we do that? Stupid wind. So we can either just before we take the bearing, set the compass to north and then align the map with it. Or we can now just set the compass to north, but we don't have this line, the outside of the compass of the base plate is now not showing north because there is a deviation between the actual north of the magnetic line here with the needle and the base plate because of course we have an azimuth in here. And in this case we can just align the grid lines or the border of the map, but I'll use just the grid lines with our azimuth lines that I showed you before. So let's set the compass north and then make sure that the grid lines are aligned with the azimuth lines. Perfect. Now this map shows exactly north. And then I can just go ahead and move the compass around until I get the bell tower that is up here. Make sure that the compass shows north and then just draw a line. This is the first version. Frankly, I don't like northing the map, so I'll show you how I do it. The second version of how to do this is to not north the map, to completely disregard the magnetic needle, just to make sure that you align the meridian lines with your grid lines. And let me just briefly do that. We have a grid line here and our meridian line. And the only downside is that you have to actually move your compass along the grid lines, right? So we have the bell tower over here and I just have to make sure that I hit it by staying on a grid line with my meridian lines. And that's this. Okay. Now I'm on the bell tower. My meridian lines are aligned with my grid line and I'll just draw a line down here. And this is my first bearing. Now, as I said, if you move along a known line, in my case this creek, then you can shoot one bearing and the intersection between the bearing you shot and the line you move on is your position. So I'd say based on this, we're pretty much exactly here. Now, we already know our position, but for demonstration purposes, let me just shoot another bearing, transpose it to the map so that we can see how we actually determine our position with cross bearings. So on my map, I saw that here is a sports court and I shot a bearing to this sports court. And the bearing is pretty much exactly 40 degrees. It's 38 degrees. And I'm doing the same. I'm aligning my azimuth line with one of the grid lines here, making sure that I more or less hit the grid line. Are you? Here you are. Whoop, here we go. And then I plot the line. Whoop. And you can see the lines intersect exactly here. Also with the second bearing, we have reconfirmed that this is our position. And this is how you determine your position with a compass and a map. I hope this video was somewhat helpful for you. If you liked it, please give us a thumbs up. Follow the channel. Thank you very much for your time. I appreciate it, and we'll see us next time.